Um, Anybody need more time to get onto the internet? Bless you. Okay, so I mean, today I'm just really going to talk about the structure of the class, what we're going to do in the class, go through the syllabus, go through the grading structure. For the people who've done this twice already in my other classes, this one is a little different than the other one, so at least you won't be listening to the same thing for the third time in a row. So everything that we're going to do in this class starts at D2L. So to get into D2L, when you're on the main Normandale page, go to current students, D2L. And it'll give you a list of all your classes, and this is 1020.
I wonder if they cut the power to it.
Oh,
I can hear it. I'll see. Maybe that's hopefully just a manual thing.
okay. And this is engineering 1020. So to go to the D2L page for this class, go there. And the first thing you see when you get into D2L for an individual class are the announcements. Just get in the habit of checking the announcements every day for this class. Anytime I change something or assign something, or anytime I want you to know a date of something or whatever, I'll put an announcement in here. So this will just populate little by little as we go. Mostly we're going to be going through the syllabus today. That's in content, and I'll talk a little bit about the other stuff in content too. You can see there's some lecture notes and lecture videos, some assignments. A lot of this stuff is going to get adjusted as the semester goes on. The syllabus is in this section called course information. And before I get into the syllabus, one thing I want to do is, this is just the opinion of one well-known product designer. But as sort of an introduction to what we're thinking about in this class, we're really thinking about product design, like what it means to design a product well. And we're using that kind of as a platform. As a platform to learn, to get introduced to a lot of different sort of engineering techniques and things like that. But let me just talk about what this one person, Dieter Rams, thinks of as the 10 principles of good design. And this is kind of a list of 10 things that we're going to continue to sort of think about as we do our projects this semester. So here are the list of 10. If you talk to other prominent designers, they might come up with different lists, but I think, this covers the basic ideas pretty well. So what does it mean to have a good product design? So first, good design is innovative. I think that sort of speaks for itself. Like if you're just copying something that someone else has done, it might be a good design, but it's not your design, Good design makes a product useful, which means that the choices you make for how what buttons are here, what the shape of it is here, makes the product more usable. Traditionally, product designers have been very concerned with aesthetics. And so, the idea that good design is aesthetic, I think that's just sort of like you want to have it as part of your surroundings, It's not an eyesore. It doesn't make you annoyed that it's sitting in your living room or whatever. Good design makes a product understandable. So that's saying that if you design something well and thoughtfully, you don't need a lot of manuals and stuff for people to be able to use it. It makes sense how you would use it. Good design is unobtrusive. Again, this is just, it manages to fit itself into your life. Good design is honest. It doesn't suggest that it's usable for things that it's not. That's sort of related to simplicity, which is something that we're always going to shoot for. Good design is long lasting. And mainly that just means you're not designing something that looks cool with the current fashions or, fits current trends or whatever. It's something that'll be usable for a long time. Good design is thorough to the last detail. Every single thing that's done on your product ideally is done for a reason. Nothing is just done because that was how you happened to slap it there. Good design is environmentally friendly. This list was made in the 70s. So this was before people started worrying about global warming and things like that. But it's just, it's kind of related to the long lasting thing. Like, if you design something well, it doesn't need to be replaced regularly and, thrown away over and over again. It doesn't break. And then good design is as little design as possible. Again, that's just related to the idea of simplicity. We're always trying to make things function in as simple a way as possible. I think the best current sort of modern example of just a brilliant design is the iPhone. And now other companies do the same thing. But when the iPhone came out, it just looked entirely different from any other cell phone that was available. The idea of no buttons was brand new. The idea of a screen that was that big, so big you could actually watch videos on it and stuff, was brand new. None of its functionality really was anything that hadn't already been done, but it just made everything so usable. It made you want to have it as part of your daily life so much that it just revolutionized everything about the way cell phones are done. So anyways, this is just a list of 10 things. Again, one guy's opinion, but we're going to keep coming back to this list as we work on our design projects, because I think a lot of times thinking about this list of things can help you sort of hone down your design into something that you feel good about. And what kind of products are we going to design? We're going to do really a couple big things. We're going to do one sort of mechanical thing using a 3D printer and using the Fab Lab. And then we're going to do one robotics project at the end, which is going to be the big thing. And so you'll be doing some stuff with CAD design. You'll be doing some stuff with electronics. You'll be doing some stuff with programming. But always, whatever we do, we're just going to try to keep these principles in mind. Okay, so let me go through the structure of the syllabus now. So this is Introduction to Engineering Design. It's a 4-credit class. It's 4 credits means basically 4 hours of class time per week. We only have 2 hours in-person class time, which means this is split kind of 50-50 into in-person and online. And so around the time class is done every week after our Tuesday class, I'm always going to have videos or, assignments or whatever on D2L for you to work on for the other half of your stuff for the week. My name's Gaio Lakin. Please just call me Gaio. my background is I have a undergrad degree in math and a master's degree in biomedical engineering, where I did like biomechanics stuff, muscle and joint forces, and body accelerations, things like that. And then I worked in that area for a while, and then I went back to school and did a PhD in sort of like engineering math, basically like applied math of uh, solid mechanics, fluid mechanics, and dynamics of bodies. Um, and so if you keep studying engineering, and if you're in sort of more of a mechanical area and less of an electrical area, going in that direction, then you'll take a bunch of classes from me here. My office, this is wrong, but my office is actually just down the hall here. I'll get that updated on the syllabus. But for office hours and stuff, you won't come to my office. I do all my office hours in the tutoring center. So, you might not need my office too often. You can get a hold of me through email or, my phone, leave messages if I don't answer. But the best way to get a hold of me is actually for stuff that, you need a reply to, which I guess is everything you would ever contact me about, is the instant messenger on D2L. So that's this mail icon up here. And if you send me a message through that, it's just a lot easier for me to keep the things that I need to get back on organized. Emails, I just have emails coming in from so many people, students, but also mostly like non-students and stuff. So this just keeps all my student stuff kind of in the same place, and it just makes it easier for me to keep track of. Okay, class time, room. My office hours are Tuesdays and Thursdays from 1 to 3. So today from 1 to 3, if you want to talk about anything, I'll be at the tutoring center. Also, I'm always happy to meet outside of class if you want to schedule, or outside of office hours, if you want to schedule something or schedule a Zoom or whatever. The only prerequisite for this class is college algebra, so it's not going to be a very math-heavy class. And so the topics that we're going to cover, the overall topic is this idea of good engineering product design. But we're going to do that by using a few different sort of sub categories. So I'm first going to just talk about the engineering disciplines, because not all of you, but I know most of you are sort of early in your engineering studies. So we'll talk about what the big branches of engineering are, what some of the smaller branches are, and a couple of those, we're going to pick ones that are especially relevant in the Twin Cities. So we'll start getting into that with lecture videos and stuff after class is done today. We'll talk a little bit about the history of product design. I'll try not to overdo that. But I just think it's really interesting. So we'll talk about the history of thinking about product design as a discipline, which it really never was until the 20th century. People didn't think about product designers as like a specific class of professionals, but sort of developing in Germany primarily in the early 20th century, it became a thing that came largely out of like modern art, actually. It's sort of cool. So one or two people last semester told me they thought that we did that too much. So we're going to do a little less of it this semester, but I'll still get it in. And then the engineering topics that we're going to do, we're going to start working on, get you used to computer-aided design. We're going to use Fusion 360 as our CAD program. And we're going to talk about how you use that to 3D print things and how you would use it to create things on a CNC mill. That stuff is all just really amazing. If you haven't used 3D printing or anything like that before, uh, to just think of something, an object, a product, in your head, and then create it on the computer, and then build it in the 3D printer, and then you're holding it and it actually does its thing, is just like I remember that just being the most amazing thing to me when I first saw it. And it's the same thing with CNC mills. CNC stands for computer numerically controlled. So it's just a computer controlled mill. And we have one in the back over here in the Fab Lab that can mill out materials as strong and hard as titanium. So sort of similar to the 3D printer, except you can actually make things out of steel and aluminum and presumably titanium, although I haven't seen us use this one for titanium. So that's going to be sort of the first section that we'll get into, computer-aided design. Then we'll start talking about electric circuits. We'll start getting used to circuits calculations, and then designing circuits that have currents and voltages of what you want, where you want it in the circuit. Sort of related to that, we'll talk about how to read data sheets of electronic components, so that like if you buy something at Axeman or Radio Shack or whatever, like how do you know what amount of voltage you need to feed to it in your circuit to make it do what you want to do? What's the most current that it can handle? How to read that off of data sheets. And then we'll do a little introduction to programming. And I'll try to talk about programming in a way that it's useful. So we're only going to use one programming language. It's just the language that you need in order to use our Arduino microcontrollers. But I'm going to try to talk about it in a way that it's useful when you go to study, other languages. Like most of you will have to take C and C++ programming. But the principles, so many of the principles are the same if you sort of think about it in a general way. Actually, when I was a junior in college, I had started taking a little bit of programming. I was a math major, and I guess really the way that I got into engineering, this was sort of the first step. I did an internship at Iowa State University doing kind of biomedical related research for the summer. And I was doing mostly just sitting and programming for their project they were working on. And I asked the guy who sort of supervised me, I asked him one day, because he was like, what language are you using? And I said, C. And he said, okay, like I don't really use C much. Like, let me get a reference book, And I asked him how many computer languages he knew, because to me at the time, I was sort of like, yeah, you study a computer language. Like I studied C and I studied Fortran. And then, so I said, like, how many computer languages do you know? And he said, all of them, I guess, like he didn't really understand the question. And I didn't understand his answer at the time. Like that didn't make any sense, But the idea is once you start to see the similarities between all these different languages, it just becomes almost like all you need is a translator book, to say like, okay, now I want to write this thing onto the screen. How do you do that in this computer language, And then the last big project, sort of putting a lot of these things together, is a robotics project. That's going to be a group project. So as we're going through everything here, consider the fact that in the last 6 or so weeks of this class, you're going to be divided up into groups. So, start thinking about if there are people or people that you think you'd work well with. Start thinking about what groups you'd like to be in at the end of the semester. But that's just a way to put all of this stuff together. We're going to use 3D printed parts. You're going to have to do circuits calculations. You're going to have to figure out how to use electronic components that you haven't used before. You're going to have to program the microcontrollers. And so it's putting everything together into a robotics package. And again, as we refine it, we're going to, with that big robotics project, we're going to try to take into consideration the principles of good design. So before I get into grading and things like that for this class, anybody have any questions about the overall class? So, I'm intending it to be kind of an introduction to what engineering is, how you branch engineering into the different disciplines, and then a little bit of what product design is, and then also a little introduction to some important areas of engineering that you'll go into depth in as your education goes on. Most likely the grading scale is just going to be 90, 80, 70, 60. Sometimes I curve that a little bit, but if I do, it's usually not very much. And so it's, 90, 80, 70, 60 gives you a good sense, I think, of where you're standing in the class. I'll try to keep your grades updated. So on D2L, you can always look like right where you're at as grades come in. And the grade breakdown is going to be lecture quizzes, 10%, and then 30% for each of the three other things, the weekly assignments, the exams, and the robotics project. So that robotics project is going to be notice that's a really big chunk of your grade. And so now I'm just going to go through these 4 different categories and just talk about what they are. So all class meetings at least until later in the semester are going to start with a 10-minute lecture quiz where I'm just asking short answer questions about stuff that I've talked about in class in the last week, or stuff that I assigned through videos or readings or whatever in the last week. And so this is just my way of making sure that you're paying attention to the stuff that I'm asking you to watch and listen to and stuff. I try to make it sort of big picture questions and not focus on like too much just intricate detail or whatever, but it's just asking questions about what I think is important to pick out of the assignments. There are no calculations in those quizzes. It's just totally like, do you remember this? Do you remember this? And I will always do that in the first 10 minutes of class. If we do 10 of those, since all the quizzes add up to 10% of your grade, if we do 10 of those, each quiz only accounts for 1% of your grade. So each individual one isn't very significant, but they add up to a letter grade. But because each one is worth such a small amount of your grade, I'm not planning to do any makeups for those quizzes. If you know ahead of time that you're going to miss stuff and we talk about it, I probably could be flexible on that. But I'm not going to do anywhere you just weren't at class that day. It just logistically it just isn't really worth it for how little each quiz is worth. Also, I'm going to do them right at 10 and I'm going to pick them up right at 10:10. So it's my way of encouraging you to be on time for class. Okay. Any questions about the lecture quizzes? And then the weekly assignments, these are just going to be the things that I ask you to turn in every week. So when we leave here on Tuesday, Shortly after that, if you go to D2L, there'll be an assignment for the week, and that'll include a bunch of, things to write, paragraphs to write or whatever, or problems to do. And those are your weekly assignments. And for the written things, it makes sense to just type them out. For the calculations, I think it's actually better for you to write them out in pen or pencil on paper. And the way you will turn stuff in is there are no folders here yet, but if you go to assignments in D2L, there'll be a category that says weekly assignments, and then there'll be one that says assigned on, whatever, Tuesday, August 26th. And that'll be a folder that you can submit PDFs to. So it's easy to submit a PDF of something you've typed. For later, when we get into hand calculations, anybody who has an iPhone, there's actually an app built into the iPhone that lets you create PDF scans out of, so if you have a sheet of paper, you can scan it really easily using the iPhone. For anyone who has other types of phones, it's easy to find free apps that do that. You also can use scanners if you want to use a scanner, if you have one available. But what I want for every assignment, say an assignment is 4 pages long or something, I don't want 4 separate PDFs. I want one single PDF document. So if the first time you try to do it, you can't figure out how to do that, that's all right. But let's figure it out soonish, Okay, so those are the weekly assignments, and those add up. So we have 16 weeks of this class. Pretty much all of those weeks, you're going to have some kind of weekly assignment. And all of those together add up to 30% of your grade. So again, each individual one isn't worth a ton, but they add up. Then the exams, there are going to be 3 exams. And these are the dates of the exams. I'll tell you well before the exam comes what topics you should be ready for on those. One thing to note about these exams is they're always going to be cumulative. So as you prepare for them, you need to go back to the beginning of the class to restudy material, not just like since the last exam. I just think it's important for trying to remember all of the stuff. When you leave this class, I want you to feel like you remember what we did. You could describe to someone what this class was about. You could describe what you did. And so that's why I think it's important to always keep going back to the beginning and refresh your memory about it all. The exams will always be very closely related to things that I've asked you to do in weekly assignments. So it's not going to be, you're never going to be asked to do some crazy thing where you have to do a ton of like creative thinking on the spot or whatever. It's mostly just making sure that you're being diligent about doing the assignments and remembering how you did the assignments and stuff. And then the last one is during our scheduled final period. One thing, this is new. So don't blame me, blame AI for this, but we have to do all the exams and quizzes in one sitting. So you can't go out to the bathroom or whatever during exams and during quizzes. If there's an issue with that, we can deal with it, but I just can't grade any exams where, you do part of it and go out into the hall and come back. It's just not really possible to trust that anymore, I don't think. Any questions about the exams? And then it doesn't say anything here about the robotics project, but we'll talk more about that as the semester goes on. I can be very flexible about what kind of things you do for a robotics project. I think, in a way, the more creative, the better. Uh, it's not much fun to just see the same thing over and over again unless you approach it very differently. But last semester, somebody did an alarm clock, which it's sort of maybe a stretch to call an alarm clock a robot, but they built physical components for it. They thought carefully about how they wanted it to look and interact with the user. They did the programming, the wiring, and it was phenomenal. And so that, to me, that was a robot project, and it got full points. Like, it was great. But we'll see. You can also do things that with big moving parts and stuff, and we'll talk about how to use programming and electricity to power sensors and arms and everything. People love that. The first time I taught this class a long time ago, I just thought that was the funnest thing in the world, like building something that moved and reacted to inputs. Anybody have any questions about? I think that's really it. So cheating is mostly AI now, or it can be copying another student's work. If you're caught cheating, there are consequences listed here. I say in all my other classes that AI just is not intended to be a part of the class, and so anytime you're using AI, you're doing something that I don't intend. This class is a little funny in that way, and so I would say that when you're doing the robot project, AI, and I'll talk about this more later on, but AI is allowed as you're using the robot project. You're just trying to get used to using whatever resources are available to you to come up with something good, a product that you're proud of, but when you're doing the weekly assignments, like calculations and whatever, and when you're writing summaries of things, I expect you not to be using AI for that stuff. And then that's kind of the end of this. There's some stuff below if you're interested in reading some resources that are provided by the school. So, okay, that is all I have to say for today. Look on D2L today, and your assignment for the week will be up there with some videos to watch and some written summaries to do. And then next week, we're going to start doing CAD programming. So anybody who has a laptop that you can bring in, if you would bring that in, that would be great, because we only have, I think, 8 desktop computers here, and it'd be helpful if everybody has a computer in front of you when we start doing CAD programming. So if anyone wants to hang around and talk to me, you're welcome to, but otherwise that's it for today. So you have plenty of time to go get ice cream or whatever you want to do.
Doesn't help you remember the Wi-Fi.
What?
Doesn't help you remember the Wi-Fi.
Oh, yeah. I hope.
Yeah. If not, that's good. Okay, let's see. I'll get on there now. No. I have a lot on this. Work. I find myself, so I put myself with all my projects, so I always have too much going on. I dug out a weed board when I was rapping. So
Let's try.
that was a lot of work. You go with concrete before? Yeah, kind of, not like that, but it turned out with one of the parts on how to it's not perfect.
So, and it just has you like no website on it. And if you go to Unreal, I started
Yeah, dude, I got a quote from 16. I did it for I got a quote.
This one?
Yeah.
Let's sign in. There we go. Hi.
Just had a couple questions.
Yeah.
So one with the quizzes, I was just wondering, do we kind of know like ahead of time, or do we just assume like when we come in that there's probably gonna be a quiz?
For now, yeah, just assume there's gonna be one. There's gonna be one every time. I think later on when we start spending more of your time working on projects and stuff, then it'll be a little more of a question, and I'll try to remind you that like we're not doing one this week or whatever. But it's just like for now, all the assignments are going to be read this, do this, whatever. So it lends itself pretty well to quizzes and stuff.
So pretty straightforward.
Yeah.
And
But
then-
so that'll be for the first 8 weeks at least or something. And then after that, we'll probably do it less often.
Okay. And then my other question, so with the CAD software, you said Fusion 360,
Mhm.
right? I haven't used that one yet, but do you know, like, is there any kind of like minimum specs for that, like laptop?
Not really, because when I use it, I actually do their online environment and it works great.
Oh,
So
really?
yeah,
Oh, just online.
just over the network.
Oh,
So
so not even like, I mean, you could download the app if you want.
yes, correct.
But like,
Right.
it might be easier to like,
But I
save
just
stuff
use
or-
the internet environment, and I've really never had any problems
Pretty
with it.
similar. Okay.
So just cloud based.
Right.
pretty
So
much?
Fusion
Yeah.
360, got it. Okay.
Yep.
I'll look, check that out.
Okay, great.
Thank you.
Yeah, sure. Bye. Hi.
I wanted to introduce myself.
Yeah, hi.
I'm Noah.
Noah. Hi, Gaio.
Nice to meet you. I am a PhD student.
Okay.
High school senior
Uh-huh.
at St. Louis Park.
Okay. We live in Hopkins, so right over there. Yeah.
Yeah. So after this year, we're going to college to study aerospace engineering.
Yeah, cool.
So
It's because they have direction check.
All right, great.
yeah.
Actually, my PhD department is technically the aerospace department, but I was in like sort of a branch of aerospace at the U.
Yeah, no, I
Yeah.
Okay.
I'm very excited for this class.
Cool. It's gonna be good. People love this class, and I do too. So,
I still be
Yeah.
half
all right, nice to meet you.
half diesel.
Hi.
I was in the static class yesterday.
Yeah.
Do you remember? I did the vector assignment, like 1 through 7, like you said.
Yeah.
I just didn't see like the assignment page on D12 to.
Oh,
actually
you're
submit.
right. I haven't put that up. I'll put that up right this.
And then there were like
before I leave
you also
here.
said there was like something we have to write in the comments section, like
Yeah.
what exactly was it again? Or it's
Just- Just I think it was 3 things you found notable about the syllabus,
Okay.
and 3 things that you found notable about the vector review. I think that's what it was.
I guess not the vector.
Yeah.
If I have any questions on that, I can just shoot you like a D2L message, right?
Yes, for sure.
Okay.
That's